Hello friends and welcome at my channel. Today I would like to talk with you guys about some properties of the function x to the power of 4 minus 3 divided by x. Obviously x is not allowed to be 0, but what's happening next? So the domain is everything but 0. Number 2, we are going to figure out symmetry. Is there a symmetry? Well, obviously we're not going to be symmetric considering the y-axis because of the x in the denominator. Let's see. We're going to get minus x to the power of 4 minus 3 divided over minus x. So minus x here is gone. It's x to the power of 4 minus 3 divided by minus x, which is minus x to the power of 4 minus 3 divided by x, which is minus f of x. So we're not symmetric considering the y-axis, but we are perfectly symmetric considering the origin, which is nice. Number 3, what about the behavior of the function towards plus or minus infinity? So if limit of x towards plus infinity is being considered, obviously x to the power of 4 is easily winning, and we are going to get plus infinity. And, well, we're going to the right, and we're going up. So, and we're symmetric, so we're going to the left. Let's see. We are going to minus infinity, right? Because of the minus sign. So it's huge positive. This is negative, but the numerator is winning. So we're going to get minus infinity. Easy breezy. Number 4, 0 points. X to the power of 4 minus 3 divided over x equals to 0. Well, if you remember, the numerator is 0. And the denominator isn't 0. This is the case for a fraction. The denominator cannot be 0 because we already excluded x being equal to 0, so we're just only solving this one. That means x to the power of 4 is being equal to 3, and we are going to take a fourth root, which gives us plus minus fourth root of 3. All right, so we got 2 0 points, 0 point and 1 is minus fourth root of 3 and 0, and 0.02 is fourth root of 3 and 0. All right, number 5, extreme values. We're going to find a derivative. Let me write the function itself here correctly, the original function, and now we are going to produce derivative. We are using the quotient rule, as you know. So this is 4x cubed times x minus x to the power of 4 minus 3 times 1 divided over x squared. So we are going to get to 4x to the power of 4 minus x to the power of 4 plus 3, which is still divided by x squared, of course, and which is 3x to the power of 4 plus 3 divided over x squared. And here we go. We have no 0 points for the derivative. It's the problem? Well, it's not a problem, but we have no extreme values here. It isn't a problem, it's just a property of a function, right? So we know it goes to plus infinity if x is increasing, and we know it goes to minus infinity if x is decreasing, but this is the way it is, so it's never 0. Even more, we're always greater than 0. All right, what about the second derivative? Let's do it again. So we are going to get to 12x cubed times x squared minus 3x to the power of 4 plus 3 times 2x divided over x to the power of 4. Okay, what's happening? We're going to get 12x to the power of 5 minus 6x to the power of 5 minus 6x divided over x to the power of 4. I cannot simplify it any further, but I can, denominator and the numerator, but I can simplify the numerator, which is 6x to the power of 5 minus 6x divided by x to the power of 4. So we can cancel an x value, knowing that x is not 0, it's possible. So this is 6x to the power of 4 minus 6 divided over x cubed. We can kick 6 out. It would be x to the power of 4 minus 1 divided over x cubed. Is it better? Well, yeah, it is, because we get 0 points here. So what about the points of inflection? Are they possible? Seems to be like this. X is obviously plus minus 1, right? In any case that x is plus or minus 1, we're going to get zeros here. And normally we just have to put, we could compute the third derivative, and we could check whether we are positive or negative in the third derivative at plus and minus 1. But first of all, we have symmetric property, which makes it easier for us. And secondly, we can just say, well, what will happen if we're going to put into the value of the second derivative here, so f second prime, something greater than 1. And I'm only interested in sign, because I already know at 1 I am having a 0 value for the second derivative. So what's happening at 1.1? This is slightly bigger than 0 here. This is positive, so everything is positive. Positive, it is positive. What about second derivative at 0.9? The numerator is going to become negative. The denominator remains positive, so it's a negative value. So there's a change of sign, which is perfect. So we have a point of inflection. Point of inflection, which is easy to compute twice, right? Because of the symmetry. So point of inflection 1 is at minus 1. If I'm putting minus 1, I'm going to get 1 minus 3, which is minus 2, divided by minus 1, it's 2. So minus 1, 2. And the second point of inflection going to be 1, and this time minus 2, because of the symmetry. All right, so the seventh property should be the graph, the seventh step. But let us see what's happening in the seventh step here if we're approaching 0 from the right-hand side. Knowing that we have symmetry, we are going to change it a little bit and already know what's happening from the left-hand side as well. So we have a slightly positive value, which is not helping the numerator. It's still negative. Dividing by a small positive number makes it huge and negative. So we get minus infinity, and obviously doing the same stuff, but coming now from the other side, we are going to be we're going to go to plus infinity. So what's happening with the graph? Well, what about the 0 points that we are having? The 0 points are minus fourth root of 3 and plus fourth root of 3. So this is minus 1 and this is plus 1. Somewhere here, so we're somewhere there and somewhere here as well. All right, then we have minus 1, 2, and 1 minus 2, somewhere there. And if we are going towards, maybe I'm too close to show my graph. I don't know. Okay, I'm going to plus infinity like this. Point of inflection, maybe I should, having a feeling it should be slightly different, slightly tighter. So the difference here must be a bit bigger, something like this. I'm saving myself. So I think now I have everything. Don't forget I'm going to be symmetric as well. So point of inflection is right here. This is the first graph, something like that. And I must be symmetric, so I must be coming this way. And if I'm going to plus infinity, I'm also going to plus infinity. Am I right? Yeah. Something like this. Okay, so I'm writing x to the power of 4 minus 3 divided by x. And I'm making a picture as well, so this is going to be my thumbnail on the video. Thank you guys for watching, and see you in the next video. Bye bye.